Part 4 of the topic 3, money-time relationship, which is deferred annuity. Now let's go with deferred annuity. Recall, the first type of annuity we have discussed was the ordinary annuity, and now this is the second, which is called the deferred annuity. Now what is deferred annuity? Deferred annuity is where the first payment is deferred. Deferred meaning delayed or postponed for several interest periods. Now as you can see in the cash flow diagram here, at the start of your investment, or let's say borrowed amount, you did not pay immediately after the first period, but instead you are given a postponement, or your first payment was delayed for several periods. For example, here your first payment was delayed for several periods, and you just paid at the end of the fifth period. So this is what deferred annuity means. Okay, now what's the advantage and disadvantage of deferred annuity? So advantage, it's very obvious. Once you've started with your investment, you will not pay immediately, but you will have time to let's say find a way to make your first payment. So that is the advantage. While the disadvantage, even if you started paying late, but the instant you made the investment, the interest started counting already. Let's say in the first period, there's an interest already. In the second period, and the third period, and the fourth period, and so on. Okay? Even if you've started paying late, the interest started counting already. So that's the disadvantage of deferred annuity. Now, how to get the formula for the present amount and the future amount of deferred annuity? First, you have the present amount here, the formula. It's a bit different when you compare it to ordinary annuity. You will have present amount equals A times 1 minus 1 plus I to the power of negative n prime divided by I times 1 plus I to the power of m prime. So this is for the present amount. How about while for the future amount, you just have to use the formula for compound interest. F is equal to P times 1 plus I to the power of n. Now, as you can see, n here and n prime is different. Okay? N is, that would be the last period. N prime here is different. Now, how to get n prime and m prime? Okay, I have added here, take note, m prime and n prime should be counted in terms of interest periods or compounded periods. For example, if problem is compounded monthly, then m prime and n prime should be counted monthly. Or if problem is compounded semi-annually, then m prime and n prime should be counted every 6 months. Now, you're not going to count n prime and m prime let's say every per year or yearly, no? You're not going to count it like that. You have to count it in terms of the compounding of the example. Let's say your example is compounded monthly, so you have count the m prime and n prime in terms of monthly. You have, let's say, semi-annually, then count the m prime and n prime semi-annually or every 6 months. And also m prime will start from the beginning until one period before the start of the first payment, while n prime will be the remaining period after m prime until the last payment. So to determine m prime, okay, it will be m prime will start at the beginning until one period before your first payment. So again, I've stated it perfectly. Period. One period before your first payment. Let's say your period is monthly. So 1 month before your first payment, that will be the end of your m prime. Let's say your period is semi-annually. So 6 months before your first payment, that is the end of your m prime. Okay? Let's say quarterly. So 3 months before your first payment, that is the end of your m prime. While for n prime, okay, the end of your m prime basically is the start of your n prime, and until the last period. That is what comprises of your n prime. Okay? So again, n prime is different from n. Okay? So this is your n prime here, and this is your m prime. Again, m prime from the beginning until one period before the first payment, and the remaining periods until the end of time will be your n prime. Okay, so how about we have an example for this deferred annuity. Example 1. A lathe for a machine shop costs 60,000 pesos if paid in cash. On the installment plan, the purchaser should pay 20,000 pesos down payment and 10 quarterly installments. The first due at the end of the first year after purchase. If money is worth 15% compounded quarterly, determine the quarterly installment. Okay, for this example, you have the price. The price of 60,000 pesos. So again, if paid in cash. So that is the price. Remember, price is the present amount. Now, on the installment plan, you will have a 20,000 peso down payment and 10 quarterly installments. So this will be every 3 months counting. So 10 quarterly installments, first due at the end of the first year after purchase. So here for the cash flow diagram, let's say this is your first year. After 1 year, that's the time where you started with paying with your machine, which is worth 60,000 pesos. Of course, again, down payment is at the start because it is considered as a present amount. Okay? Now, 10 quarterly installments. So, starting at the end of the first year, you will have 10 quarterly installments. So, I have here, every year, I divided it into 4 segments. So, first year, you have first payment, then quarterly, okay, for until 10 installments. Okay, so it ended up at 3 months after the third year. Okay, so if we're going to look at the given, you have again the price of the machine. You have 60,000. You have the down payment 20,000. And the rate interest of 15% compounded quarterly. Now, everything is given. So, we can just directly substitute all datas in the formula. Now, before we proceed with substituting all given into the formula, we have to determine first m prime and n prime. Okay, so for this problem, considering interest is at compounded quarterly, okay, so again, m prime, you will have at the start, and the end of your m prime will be 1 period before your first payment. Since in this problem, this is compounded quarterly, so you count 1 quarter before your first payment, that will be the end of your m prime. And with this, the end of your m prime, this will also be the start of your n prime. So, this will be the start of your n prime again until the end of your period. The end of your period, of course, is when the last payment is made. Okay? For this one, since I've made a cash flow diagram until the 4th year, you will not go until the 4th year because the end of this problem is until only the last payment. So, this will be the end of your n prime. So, determining m prime, so again, no, you have to count it quarterly because this problem is compounded quarterly. So, m prime will be, you have 0, 1, 2, 3. So, m prime is 3. How about for n prime? So, the end of your m prime is also the start of your n prime. So, if this is the start of your n prime, this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, your n prime is 10. So, with this one, we now have already a value for m prime and n prime. So, we can directly substitute now to our formula. Okay? Directly substituting. Okay? Now, but remember, you have a down payment. And recall from our previous discussion, down payment is part of the price. So, your price DI will be the down payment plus the total of your annuity. Okay? So, you will have price is 60,000. Down payment is 20,000. Plus the formula A times 1 minus 1 plus the rate 15% divided by quarterly 4 minus 10. Remember, n prime is 10. Then over I, 0.15 over 4 times 1 plus 0.15 over 4 to the power of 3. Remember, m prime is 3. Okay? So using the calculator in solving this problem, you will arrive with A is equal to 5,439.18 pesos. Okay, we have another example, example number 2. An engineer desires to establish a fund for which he will deposit a fixed amount every half a year for 5 years. Half a year after the 5th year, he will then start to withdraw 10,000 pesos every half a year for another 5 years. If the fund established will be at an interest rate of 5% compounded quarterly, how much should the fixed deposit be? Okay? Now, this will be the cash flow diagram. Again, it's not necessary that you will have a cash flow diagram, but it's very important because it will help you see the whole process of your problem. Just like this one. So this will be the cash flow diagram for example number 2. So again, for 5 years, there will be a deposit, okay, every half a year for 5 years. So you have here, every year, I divide it into 2. I divide this into 2. So you will have payment, deposit. Then second year, deposit. So every half a year, there is a deposit. Every half a year, there is a deposit. Until the 5th year. Then half a year after the 5th year. So another half a year, then the fund will start, then the engineer will start withdrawing 10,000 pesos also every half a year. And also for another 5 years. Okay? So, half a year for 5 years, that will be 10 moments of 10,000 pesos withdrawal. So, you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So, for 5 years, 10,000 pesos withdrawal every half a year. So, question is, how much should be this deposits every half a year for the first 5 years? Okay, let's analyze the problem. Okay, now the solution for this example, okay, in this problem, okay, there are 2 types of transaction. So, first is the payment for the fund done every 6 months for 5 years. So, this one, the deposit made every half a year for 5 years. And the second one is the 10,000 peso withdrawal every 6 months for 5 years. Now, this is our second type of transaction, the withdrawal. Okay? Again, for every half a year and for 5 years. So, first transaction are the deposits, while the second transaction are the withdrawals. Okay? Now, this is a basic example of saving now for use later. So, you are saving now in a deposit fund so that you can make withdrawals after a certain period of time. So, save now, okay, so that you can withdraw something later. So, of course, what you have withdrawn is just equal to the deposit. Okay? So, basically, your deposit is just equal to your withdrawal. But, okay, but together with the interest if coupled with time. Okay? Kung wala lang yung time nga involved, kana imuhang deposit, mura po na imong makuha, ma-withdraw. Pero, for this one, naa na may time nga na-involve. Again, just like our topic, money-time relationship, basta naa ganay time ma-involve, naa ginay interest. Okay? So, here, instead nga maingon ta nga equal ra man gid unta na ang deposit nimo gimuhang withdrawal, we cannot say so na anymore because coupled with time, there is interest already. Okay? Now, very important to remember, without the effect of time, your deposit is equal to your withdrawals. Okay? Without the effect of time. For example, if I'm going to determine the amount of my deposit and the amount of my withdrawal at the same period of time, let's say how much is the amount of my deposit on the 5th year is also the same amount of withdrawals on the 5th year. Okay? So without the effect of time, there is no effect for interest. They should be the same always. Okay? So again ha, basta the same time period gani, equal ra gyud na kung parihas ra og basis. Example, on the first year, parihas ra na ang withdrawal og ang imuhang deposit. Okay? Second year, ang imuhang total sa deposit, parehas ra pud na sa total sa imuhang withdrawal kung sa second year. Okay? So, parehas ra ni sa katong gi-example before no nga, pwede dili nimo pwede ma-compare ang piso pag year 2000 ug ang piso pag year 2020. Pwede ra nimo sila ma-compare kung ang piso pag 2010 i-compare nimo pila may equivalent anang piso sa 2020 kung ari nimo ibutang sa 2010. Okay? So equal ra na sila basta same og time period. So this will be the main point to consider in solving this problem. Okay. Now, to realize the previous consideration of deposit is equal to withdrawal, the total amount of all the deposit should be equal to the total amount of all the withdrawals. Okay? So, muna kong gingon before, na ang total ani, equal ra gyud na sa total ani. Kung same nga time. Okay? So, these two total amounts should be at the same time period. So, kung equal man ganin na sila, dili ka pwede mag-equate nga lain-lain nga period. So, pare sa piso, dili ka pwede mo equate nga ang piso sa 2000 ug piso sa 2020 kay lain-lain sila og time period. Okay? So, for this one, pwede nimo ma-equate nga ang deposit pag second year ug ang withdrawal pag second year. Or deposit pag start ug ang withdrawal pag start. Okay? Or deposit pag last nga year, 10th nga year, og ang withdrawal sa 10th nga year. So, no, pwede nimo ma-equate basta parehas nga time period. Okay? So, the best way to equate the total amounts of every transaction would be either using the present amount or the future amount. So, pinakadali nga ma-equate nimo silang diha is either sa present or sa future. Nga naman, how about sa first year day, sir? How about sa second year day, sir? The best thing manggod sa present ug sa future na kay formula. Okay, diretso na. Kumpara sa ari pa ka sa third year, ari pa ka sa fourth year, naabag gay direct nga formula para na wala. So, naa kay diretso nga formula kung ari ka sa present or kung ari ka sa future. So, mo nang mo'y pinakadali nga pag-equate nimo sa duha ka amount sa deposit o sa withdrawal. Okay? Now, from the two methods, using the present amount is much easier. Okay? Because if you can recall the formula for the future amount sa deferred annuity, you're just going to follow the compound interest. F is equal to P times 1 plus I to the power of N. So, para makuha ni mong F, kailangan ka og P. So, kung kailangan mo dahil kag P, may pag-present amount na lang imong gamiton para pag-compare sa duha. Okay? Kaysa mag-future amount pa ka, pwede naman lang di ay ang present, present na lang. Okay? So here, present amount of all deposit should be equal to the present amount of all your withdrawals. Okay? Again, you can only do this if they are on the same time period. Okay. The question now is how to get the present amount of both deposit and withdrawal. So, mo gid na pinaka-problema. So, ano to pagkuha? So, to determine how, we must look at the cash flow diagram. Okay? From the cash flow diagram, we can divide it into two, the deposit side and the withdrawal side. Okay? So, ato na siyang i-categorize into two types of transaction, the deposit and the withdrawal. With this, pwede na to mas simplify ang pag-analyze unsaon pag-determine sa present worth in every transaction. Okay, looking first at the deposit side, we can have the following CFD. So, ayaw lang sa atog tanawa ang katong withdrawals. Ari lang ta sa deposit. So, if you're going to look at the deposit, no, from this, you can see that the series of deposits actually form an annuity. Diba? Equal payments at equal periods of time. So this is annuity. And it is an ordinary annuity to be specific. So kung mo tanawon, ordinary annuity raman niyo. Diba? First payment is made at the end of the first period. So this is your first period, at the end, first payment. Another period, at the end, another payment. So this is just ordinary annuity. So for the deposits DI, okay, so the present amount for the deposit would be following the present, by the way, present ni ha, following the present amount formula for the ordinary annuity. So ang present amount ra dayon imong withdrawal, sundan ra nato ang present formula sa ordinary annuity, which was this one. So recall mo ni ang present amount formula sa imuhang ordinary annuity. Okay, now this time looking at the withdrawal side, okay, we can have the following CFD. So manamtag analyze sa deposit side, ari na sa withdrawal side. So if you're going to look at the withdrawal side, okay, from this you can see that the series of withdrawals actually form ni ha, dili ni form an annuity, and it is a deferred annuity to be specific. Ngano na deferred annuity man? As you can see, imuhang withdrawals, kung kana lang gid mo tan-awon, di ka magtan-aw gid na sa deposit, tanggalon to nimo sa imong unahuna. Ang first withdrawal nimo is made on, let's say, the 5.5 year, di ba? So ni take time pa o na nag-start sa withdrawal. That is basically the characteristic of a deferred annuity. So imong first withdrawal wala na nagsugod, ni delay pa or na postpone pa o na nagsugod og withdrawal. So with this, deferred annuity ra day ni. Okay? So the present amount for the withdrawals would be following the present amount formula for the deferred annuity, which is, so recall mo ni ang formula for the present amount sa deferred annuity. Okay. Now, ato na lang, unsa na to pag-determine sa N prime o sa M prime. Okay, kailangan mo gid ni para sa deferred annuity nga formula. Okay? So, from this, again, no, ang M prime, ang start sa M prime will be ang start pod sa ato ang time period. And then, ang end sa atong M prime will be 1 period before the start of the withdrawal. So, kung mo ni atong first withdrawal, mo-go back ta og 1 period. Nya, take note, this is semi-annual man eh. So, mo-go back tag 6 months or half a year. So, this will be the end of your M prime. Okay? And at the same time, ang end sa imong M prime will be the start of your N prime until the last withdrawal. Okay? So, let's count M prime. So, at the start, you have 0. Again, ang counting na to ani is semi-annual because semi-annual man ang ang type sa problem. So, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? M prime is 10. Then, how about N prime? If this will be the start of your N prime, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? N prime is also 10. So with this, the count for M prime and N prime will be semi-annually, thus M prime is 10 and N prime is equal to 10 also. Okay. But since determining how to get the present amount of both deposit and withdrawals are now known niya. Okay? So, ang sa deposit nga side, katong present amount sa ordinary annuity. Ang withdrawal nga side, katong present amount sa deferred annuity. So, supposedly, kay bawa naman tata sa formula, we can now proceed with solving the problem. But, there is still the problem of the payment, not the same with the interest. Okay? So, kung imong i-recall, ang atong problem, it has a interest of compounded quarterly. So, to be specific, 5% compounded quarterly ang kaning example. Pero ang atong payments, they are all semi-annual or every half a year or every 6 months. So, this is related to the previous discussion of the time period for payment should be the same for the compounding. So, again, basta annuity gani, recall, ang imuhang period, ang imuhang interest period, ang imuhang interest rate should always be the same with your your payment should always be the same with your compounding. So ang period sa imuhang payment should always be the same kung unsa imuhang compounding. Okay? Now, for this one, payment is made semi-annually, while interest is compounded quarterly. Therefore, the interest should be converted from compounded quarterly to compounded semi-annually. And we all know this one, how to solve this. Okay? Kay mora bay daghang wrong atong midterm exam. Okay? Kay wala man nagtan-aw nga lahi di ay ang ilahang interest rate o ang ilahang payment. So, daghang na wrong sa midterm exam. Okay? Pero gitagaan na gyapon akong points kay naka-solve man sila og initial. Okay? So solving for this will be using the formula for ERI. So you have to make do of this one first. Kailangan sa nato i-convert ang quarterly into semi-annually. So using the formulas, then atong ibutang ang tanang mga given. Okay, we can have R is equal to 0.0503. Therefore, our new interest rate nga gamito na to for this formula will be 5.03%. This time, this will be compounded semi-annually. Okay? Now, since we have everything na, how about we solve the problem? Okay, so now the new interest rate will be 5.03%, compounded semi-annually. This will be the new interest that will be used to solve the problem. Therefore, looking back again with katong gi-equate na to ang present amount sa both deposit and withdrawal, then using the formula. So recall sa deposit, this is present amount formula for the ordinary annuity. Recall po sa withdrawal, this is the present amount formula for deferred annuity. Then, atong ipamutang tanang given. Substitute all given. Okay, this time again, the rate we're using is the converted one. Okay, then, the only unknown will be A for the deposit. By using the calculator, we can achieve an answer of A is equal to 780.056 pesos. So, this is how to solve this example.